Welcome to the class, dear students. Yes, I'm so excited today to explain the analysis of variance for the statistical tests. So, to understand when the variance of three or more groups are given, then how to find out the variance. The variance is among the groups it is different, and within the groups it is different. So, how to do the analysis of the variance when three or more groups of samples have been taken, and it is under only one independent variable it is depending upon, suppose, then it is called as the one way of analysis of variance, one way of ANOVA. So if it is under only it is depending on two independent variables, suppose, then we call it as two-way ANOVA. Now in the present topic, I am talking about only one independent variable, and we are going to compare the variance which is used to compare the means of more or two groups with only one independent variable. Let us understand in a deep way about this analysis of variance. Suppose I have a population in which there are three groups have been divided. Depending upon so and so characteristics, we will divide the population into three groups, let us say. Now look at these groups. In this, if you understand, the mean of this group is somewhere here. The mean of this particular group is somewhere here, and the mean of this group is somewhere here. So what you can observe here is between the groups, that means between any two groups, if you observe, the mean is very far. That means there is a lot of variance in the mean of any two groups, between any two groups. There is a lot of variance is there between the means of any two groups. But within the group, if you observe, they are very close to each other within the group, right? So the variance in the mean within the group is very less. I hope you could understand this particular statement. When you start analyzing between the groups and within the groups, how the variance of the mean is being executed. Let us now look at this group and this group whose means are, there is a lot of variance between the means of the groups, correct? Between the groups there is a lot of variance. And within the group, the variance is very less. The variance of the mean is very less. Whereas now look at the other population where I have again three groups. In these groups, the data values are given in this way. And the mean of this first group is this. Mean of the second group is this. And mean of the third group is this. Now, I hope you are able to understand now the variance between the group. The variance of the mean between the groups is very less, correct? There is a small difference between this mean and this mean and this mean, correct? So there is a very little variance is there between the means, between the groups, okay? Now coming to the variance of the mean within the group, if you observe, the data value is somewhere here, mean is somewhere here. The variance between the variance of the mean within the group is very large, correct? So this is what happening in a situation when you have a data sets are being given, depending upon the variance of the means between the groups and within the groups. If we analyze, then we will come to a very good conclusion whether to accept the hypothesis or reject the hypothesis. This is the crucial point to understand how the variance of the means is activating between the means and between the groups and within the groups. That's a crucial point, and this is being identified by actually there is one more test which is called as F test, okay? And this F test is being defined for more than three or more groups actually. And you can say that this F test is the extension of the student's sample test, that is T test and the Z test, of course. Now, if you understand this, how to give the conclusion about the variance between the means by giving the F test. And this is being done by the famous scientist, the Ronald Fisher, and the name F test is being named on his name only, as Ronald Fisher has introduced this F test, which is giving you a very big clarity about the justification of the conclusion. So the population in which the samples are obtained must be, of course, normally distributed, and it is the extension of the normal, the small t test and the large sample z test also. And the samples must be independent of each other, and it suits for normally this particular test is suits for normally small samples only. Okay, and the variance of the population must be equal. Okay, and now, as I told you, we will take into consideration the variance between the group and the variance within the group. That means SB square stand for the variance between the groups, and SW square stands for the variance within the groups, and we will take the ratio of these two variances. When we take the ratio of these two variances, we will compare this calculated value with the F table value. There is a how you have done with the T table, Z table, the normal table, and all these tables, how you have taken the table values to find out the particular area under the curve. We will be using the table value, and this F calculated value is less than that particular table value, then we will be accepting the hypothesis. Now, how to find out the variance between the groups? When I say the variance between the groups means, first of all, for all the three groups or four, whatever, the group mean we will be finding out, and the mean of each group we find out, and take the difference of those two, the square of the difference of those two. And how many times we will be doing, how many groups are there? That means Ni times of xi bar minus xgm bar over k minus 1, because it is as I told you that it is suitable for small samples. Always when you take the small sample, if you remember 3 tests, the variance when you are considering the denominator is n minus 1. Here we are concentrating on the number of groups, so therefore it is k minus 1, where k is the number of groups. XGM bar is the grand mean or group mean, whatever you say. And SW square is within the group variance, how much it is. That means again it is sigma, because within the groups the variance we are considering. Find out Ni minus 1, that means the number of observations minus 1 times of Si square by summation of Ni minus 1, that is giving you the variance, the group variance, within the group variance. I hope you could understand. While doing the problem, you will understand more easily about this within the group and between the group, what is the variance. Now, to start with, always we have to start what is the null hypothesis and what is the alternate hypothesis. What's the null hypothesis explains you in this F test. It says that all the means, now you have 3 samples at least, right? So all the 3 samples with or different more than 3 samples, whatever the means are there, all of them are the same, mu1 equal to mu2 equal to mu3 and so on. And alternate hypothesis says that at least one of the means is different than the others. So this is what the alternate hypothesis says. So